So we're going to start the week where we talk about energy expenditure and fatigue. And we're going to start off by discussing how we measure energy expenditure, this video and the next one. And so here we've got our three objectives. And with this last one here, this one is actually on the second video. So we're just going to talk about VO2 and VCO2. We'll get into RER and RQ later on. So this one is not here either, I don't believe. Okay, so when we measure energy expenditure, it's something called, we do this via something called calorimetry. And so if we're using what's called direct calorimetry, we're trying to determine how much heat's being produced. And the way we do this is we need to know how much food we've taken in, how much oxygen we're using, take into account the work, and then what's left over is essentially the heat or that energy expenditure. All right, that's not easy to do. And so what we use is something called indirect calorimetry. And so we use VO2, which is oxygen consumption, as an estimate for energy expenditure. So it's still the same idea, but we're estimating this. And the way we do this is we are able to measure how much oxygen is coming in and how much going out, as well as CO2. And then that gives us an idea of what's going on. So with indirect calorimetry, there's going to be some math, okay? And there's going to be math on the exam. There's going to be math on the quizzes. And I'm going to make this as simple as I possibly can, okay? And so here we go. So VO2, so the amount of oxygen uptake, all we need to know is how much are we breathing in and what percentage of that air that's being breathed in is oxygen. And then we subtract the amount of air that's being breathed out times the amount of oxygen that's in that air, okay? The nice thing is VI, which is volume of inspired air, and VE should be the same, okay? So we're just going to make that assumption that they're the same. And so really all you need to know is what's the difference between the inspired and expired oxygen percentage, okay? And we can do the same thing for VCO2. The only thing that's different is we subtract the expired air from the inspired, okay? Because there's more CO2 in what we exhale as opposed to what we inhale, all right? And the variables mean the same thing. So VE, VI are inspired or expired and inspired air, or the volume of those. And then FI means fraction of inspired, okay? And there should be an E here. So this should be an E, I've never noticed that, okay? And this one should be, and this one should be an E right here, okay? So let's go through an example. So you get somebody doing a treadmill test. They're inhaling and exhaling 100 liters of air per minute. The percentage of oxygen is 20.93 because that's what it is no matter where you're at on Earth. But the percentage of oxygen in their expired air is 15%. So how much oxygen are you using? So you just take this formula. So VI times FiO2 minus VE times FeO2. So we go 100 liters times 0.2093 minus 100 liters times 0.15. Okay, and so what that ends up giving you is 5.93 liters of oxygen per minute. Okay, and depending on how big you are and how intense it is, that's actually a pretty high number. All right, so we're going to take the same thing, but now we're going to do it with CO2. So you inspire 0.04% of CO2, which is essentially zero, and then you exhale 6%. So how much are you producing each minute? Use the similar equation, but remember we go expired minus inspired. So 100 liters times 6% minus 100 liters times 0.04%, and we get 5.96 liters of CO2. Okay, when I do this, I'm almost positive, like on the quizzes and stuff, I will give you nice, easy, round numbers. I might even say just use 0% for CO2 just because it makes it a little easier. So there is some math that we get to do. And you'll see this, if you haven't already, when you are in lab and doing like max and submax tests.